Sunspot AR3664 was 15 wider than Earth, and it wasn't finished. It's not a black hole, it's not the edge of some distant, dying star, it's not a glitch on the telescope, and it's not somewhere far away. It is a scar on the face of our own sun, a dark, cold bruise, the size of 15 Earths, lined up side by side. And in May of 2024, you could have looked up and seen it with your own eyes. Its name is AR3664. And here is the part that should stop you cold. This thing was not a photograph. It was not history. It was live. It was loaded. And over 8 days, it fired everything it had straight down the barrel at the planet you are standing on right now. Today, we break down everything about Sunspot AR3664, the monster that was 15 times wider than Earth and wasn't finished, what it is, how it grew, what it did to us, and why the scientists watching it were not reassured when it finally turned away. No filler, just the facts. Start with the object itself. A sunspot is not a hole. It is not empty. It is a knot. A place where the sun's magnetic field ropes itself into a bundle so tight that it chokes off the heat rising from below. The surface there cools. Cooler means darker. That is all a sunspot is. A region a couple of thousand degrees colder than everything around it. So it reads as a black stain against the blinding white. The mechanism is simple. The sun is a ball of charged gas that does not rotate as one solid piece. The equator spins faster than the poles. That difference drags the sun's magnetic field lines, stretches them, winds them tighter and tighter like a rubber band twisted past its limit. Eventually, those twisted ropes punch up through the surface. Where they break through, you get a sunspot. Where they tangle, you get a bomb. The most dangerous sunspots have a specific magnetic signature, a tortured, mixed configuration that scientists label with a string of Greek letters, beta, gamma, delta. It means positive and negative magnetic polarities are crammed together in the same region, pressed so close that the field lines are forced to snap. AR3664 had exactly that signature. It was not just big, it was structured to explode. AR3664 began as almost nothing. According to observations logged by the Harvard-Smithsonian Center for Astrophysics, the region rotated into view on the Earth-facing side of the Sun around the 1st of May 2024. At that point, it was a modest little group. 5 small spots. Nothing that would make the news. Then it grew. Over roughly 2 weeks, that quiet cluster ballooned. The National Oceanic and Atmospheric Administration, NOAA, the American agency that runs the Space Weather Prediction Center, issued a warning on May 7th. Their language was clinical. The region, they reported, had grown considerably and become much more magnetically complex. Translation: it was arming itself. By the time it reached full size, the numbers stopped sounding real. According to spaceweather.com, AR3664 stretched roughly 124,000 miles from end to end. That is about 200,000 kilometers. That is 15 times the width of Earth. Some measurements put it closer to 16. It held as many as 58 individual dark spots inside one connected magnetic complex. Let that scale land on you. If you shrank the sun down and set our entire planet next to this one sunspot, Earth would be a marble rolled up against a dinner plate. You could have dropped 15 Earths across it in a single row and still had room left over, and it was so large that it broke a rule you have been taught your whole life. You are told, correctly, never to look at the sun. But this spot was so vast that during the total eclipse season of that spring, people pulled out their leftover eclipse glasses, looked up in broad daylight, and saw it. A dark notch on the sun with the naked, filtered eye. No telescope, no magnification. Just a stain big enough to see from 93 million miles away. That alone would make AR3664 remarkable. A curiosity, a great photo. But a sunspot that big is not a photo opportunity. It is stored energy, and stored energy is only interesting because of what happens when it lets go. No guessing, just the facts. And the facts are about to get violent. When one of those twisted magnetic ropes snaps, the sun releases the energy in an instant. That is a solar flare, a flash of radiation, X-rays, ultraviolet, the full electromagnetic spectrum that crosses the 93 million miles to Earth at the speed of light. 8 minutes. That is all the warning you get, because the flash and the news of the flash arrive at the same moment. Flares are graded by letter A, B, C, M, and X. Each step up is 10 times more powerful than the last. X-class is the top of the scale, and within that class, the numbers keep climbing. X1, X2, and on up, each number a further step in raw intensity. An X-flare is the strongest thing the sun does with light. AR3664 did not fire one, it fired a barrage. Here is the timeline, reconstructed from NOAA's Space Weather Prediction Center and from Europe's Solar Orbiter spacecraft, which watched the whole thing from its position closer to the sun. May 8th, the region lets go of an X1 flare, a cluster of smaller M-class flares, and launches several coronal mass ejections toward Earth. Hold on to that phrase, coronal mass ejection, because it matters more than the flare itself. We will come back to it. May 9th, an X2.25, then an X1.12, each one paired with a full halo eruption, a cloud of solar material blown clean off the sun in every direction, including ours. May 10th, an X3.98, peaking in the early hours. Radio operators across Asia, Eastern Europe, and Eastern Africa lose high-frequency signal, either degraded or blacked out entirely, as the X-rays slam into Earth's upper atmosphere and ionize it. That is what a flare does first. The X-ray flash reaches the daylit side of the planet in 8 minutes and thickens the ionosphere so much that shortwave radio, the kind ships and aircraft and emergency services still rely on, simply stops working over half the world. No cloud has even arrived yet. This is only the light. May 11th. Another X-flare, this one rated somewhere between X5.4 and X5.7, and it still was not done. On May 14th, AR3664 fired the big one, an X8.7. According to NOAA, that flare was the largest of the entire solar cycle up to that moment, the most powerful eruption seen on the Earth-facing side of the sun in years. It peaked in the early afternoon, Eastern Time. Then, as the sun's rotation began to carry the region toward the edge and out of view on the 15th, it threw two parting shots, an X3.4, then an X2.9, a monster refusing to leave quietly. Count them. In roughly 1 week, a single active region produced a string of X-class flares, 5 major ones in the span of about 7 days, by the count published in the scientific record. That is not a stormy week for the sun. That is one region behaving like the most dangerous object in the solar system, because for that week, it was. But the flares, the light, the radio blackouts, those were the opening act. The flash burns your skin. The real blow is the thing that comes behind it, slower, heavier, aimed. There is a third kind of threat buried in these eruptions too. Beyond the light and beyond the cloud, the biggest flares fling out high-energy protons, a radiation storm that races ahead through space. Those protons are the reason astronauts on the space station take shelter during major solar events, and the reason airlines watch space weather alerts before sending flights over the poles, where Earth's magnetic shield is thinnest. AR3664's outbursts triggered exactly that kind of radiation storm. The sun was attacking on 3 fronts at once: light, radiation, and matter. And only the slowest of the 3 had reached us so far. The coronal mass ejections were already on their way. No guessing, just the facts. A flare is light. A coronal mass ejection, a CME, is matter. It is a physical cloud of the sun itself. Billions of tons of charged particles and magnetic field, blasted into space at millions of miles per hour. Light takes 8 minutes to reach you. A CME takes longer, usually a day or more. That is your warning window. That is the entire reason space weather forecasting exists, to see the cloud leave the sun and count the hours until it arrives. AR3664 did not send one cloud, it sent a convoy, multiple CMEs, launched over several days, and because the later, faster ones caught up to the slower earlier ones, they merged in flight into a single compound wall of magnetized plasma. That wall reached Earth on the evening of May 10th. When it hit the way almost nothing in living memory has hit. NOAA rates geomagnetic storms on a G scale, 1 through 5. G5 is the top. Extreme. The kind of storm that had not touched Earth since the Halloween storms of October 2003, more than 20 years earlier. The May 2024 storm reached G5. The planetary K-index, a measure of how badly Earth's magnetic field is being shaken, runs from 0 to 9. 9 is the top of the scale. Pinned, maxed out, no higher reading possible. The Gannon storm hit 9 and stayed there. When the instrument that measures the disturbance cannot register anything worse, you are no longer in ordinary weather. But the number that makes space physicists go quiet is a different one. The APEP index, another measure of geomagnetic disturbance, reached 271 for May 11th. According to the recorded history of these measurements, that is the second highest value ever logged, beaten only by a reading of 280 back in November of 1960. The Disturbance Storm Time Index, which tracks how far Earth's magnetic field gets pushed out of shape, plunged to around -412 nanotesla, with some readings estimating it went even deeper. The deeper that number, the harder the planet's magnetic shield was being bent. This storm earned a name. Researchers later named it the Gannon Storm, after Jennifer Gannon, a respected space weather scientist who had recently passed away. When you hear the Gannon Storm, this is it. The strongest geomagnetic storm to strike Earth in 2 decades. And here is where it stopped being a number on a chart and became something people saw. Earth's magnetic field funnels those incoming particles toward the poles, where they crash into the atmosphere and make it glow. That glow is the aurora, the northern and southern lights. Normally you have to travel near the Arctic or Antarctic to see them, not that night. The Gannon storm pushed the aurora so far from the poles that people saw color in the sky in places that essentially never see it. Reports came in from Mexico, from Puerto Rico, from South Africa, from Spain and Portugal, across the United States, across Europe, across the Southern Hemisphere. Ordinary people stood in their yards and watched the sky turn red and green and violet, many of them photographing an aurora for the first and possibly only time in their lives. For most, it was beautiful, one of the great sky-watching events of the decade. But beauty and danger were the same event. The lights in the sky were the visible symptom of a planet's magnetic field being hammered. And while millions looked up in wonder, the systems you depend on every single day were quietly coming apart. No guessing, just the facts. Here is where it reaches down and touches your life. Start with something you would never connect to the sun: farming. When that wall of plasma slammed into the upper atmosphere, it created what one study described as a wall of ionospheric plasma across North America, a churning, distorted layer that GPS signals had to pass through to reach the ground. And GPS does not tolerate distortion. According to research using fixed ground receivers, positions were thrown off by as much as 230 feet across the central United States. The errors lasted, in some regions, for up to 2 days. Now here is why that mattered on the ground. The storm hit in the second week of May, the peak of corn planting season across the American Midwest. According to Kansas State University agricultural economist Terry Griffin, roughly 70% of planted acres in the United States now rely on GPS-guided equipment to drive perfectly straight, perfectly spaced rows. Modern tractors don't just use GPS as a convenience. Many of them no longer carry the physical markers farmers once used. The machine steers itself, down to the centimeter. Take that precision away in the middle of planting, and the machine doesn't just get a little sloppy. It panics. Farmers across the Midwest reported their self-driving tractors lurching and swerving during the storm. One account, reported by Space.com, described the equipment behaving as if it were possessed. Planting stopped, and in agriculture, timing is money. The estimated cost, according to the Kansas State analysis presented to the American Meteorological Society, more than $500 million in losses to Midwestern corn farmers alone. Some figures put it as high as $565 million. From a storm on the sun, during the exact days that 12 Midwestern states that grow close to a third of the world's corn, needed their GPS the most, now go up, into orbit. The same energy that distorted GPS also heated and puffed up the outer atmosphere. That expansion reached the altitude where satellites fly and increased the drag on them, the atmospheric friction that slowly drags spacecraft down. According to a study out of the Massachusetts Institute of Technology, published in the Journal of Spacecraft and Rockets, satellite operators watched their spacecraft sinking and had to fire thrusters to climb back to safe altitude. At the peak, roughly 10 satellites at a time were being commanded to raise their orbits. Thousands of objects in low orbit, including the Starlink constellation, felt the pull of that single storm. And on the ground, and in between, NOAA reported power grid irregularities and degradation in GPS and high-frequency radio. Airlines rerouted flights away from the polar regions, where the radiation and the radio blackout were worst. The same reason those routes get diverted during any major solar event. The long metal pipelines that carry oil and gas across continents pick up the same storm-driven currents as power lines do, quietly accelerating the corrosion that operators have to monitor and manage. On May 13th, the GOES-16 weather satellite, one of the very satellites that watches this kind of storm, stopped transmitting all data for nearly 2 hours before it recovered. Drone operators reported aircraft losing GPS lock and, in some cases, losing control and crashing. And in one of the strangest findings of all, researchers at the University of Victoria discovered that the storm was strong enough to swing the compasses inside seafloor observatories, sensors sitting under nearly 2 miles of ocean water. The storm reached the bottom of the sea. Now, an honest fact, because we don't guess here. According to America's emergency and energy agencies, there was no major disaster. The grid held. The lights, for most people, stayed on. Forecasters saw the storm coming, warned the operators of power and farms and satellites, and a great deal of damage was prevented by people doing their jobs in the hours before impact. That is the good news. But read it carefully. The system held because we got lucky, and because we got warning, and because this storm, as extreme as it was still not the worst the sun can do. To understand what the worst looks like, you have to go back, first to 1989, and then to 1859. No guessing, just the facts. Start with the one that already happened to a modern power grid. In March of 1989, a geomagnetic storm, smaller than the Gannon storm, smaller than Carrington, struck Earth. In the Canadian province of Quebec, the electric currents driven into the ground surged through the Hydro-Quebec grid and, in the space of about 90 seconds, collapsed it. The entire province went dark. Roughly 6 million people lost power, in some places for around 9 hours, on a freezing March night. Transformers were damaged as far away as New Jersey. That was not a hypothetical. That was one storm, one grid, one province, gone in a minute and a half. And it was nowhere near the ceiling of what the sun can do. Now go back further, to the ceiling itself. In September of 1859, an astronomer named Richard Carrington was sketching sunspots when he watched a burst of light erupt across the sun's surface. Hours later, Earth was hit by the most intense geomagnetic storm in recorded history. The technology of 1859 was the telegraph, and the telegraph came apart. Operators reported sparks leaping from their equipment. Some received electric shocks. Lines caught fire. And in a detail that still sounds impossible, some telegraph systems kept sending messages after being disconnected from their batteries, running on the electric current the storm itself had induced in the wires. Auroras were seen near the equator. In parts of the world it was said you could read a newspaper by their light at midnight. That is the Carrington event, the benchmark, the worst case in the historical record. And here is the fact that connects it directly to our story. The sunspot region that produced the Carrington event was, by the best estimates, comparable in size to AR3664. When scientists looked at the monster of May 2024, they were not reaching for a dramatic comparison. They were looking at something in roughly the same weight class as the storm that fried the telegraph. So ask the obvious question, the one you should be asking. What happens if a full Carrington-class storm hits the world we actually live in now? The world of continent-spanning power grids, satellites, GPS, undersea cables, and electronics in every pocket. We are not entirely guessing, because we have already had a near miss. In July of 2012, the Sun launched a coronal mass ejection that NASA scientists later assessed as Carrington-class, possibly stronger. It tore across Earth's orbit at enormous speed. The only reason you never heard about it as a catastrophe is a matter of timing. It crossed the exact point in space where Earth sits. But Earth had been at that point about a week earlier. We had already moved on in our orbit. The bullet passed through the space where our head had just been. Had it left the Sun 1 week sooner, it would have hit us head-on. And the researchers who studied it have said, plainly, that we would have spent years digging out from the damage. That is the shadow AR3664 was standing in. Not because it caused a Carrington event. It did not. But because it proved, in front of the whole world, that the Sun is still fully capable of building one. The machine still works, the monster spots still form. And in May 2024, one of them pointed itself at us and fired, and then it turned away. The The rotation of the sun carried AR3664 around the far limb and out of sight. You might think that is the end. The threat rotated off the board. Relief. It was not the end, because AR3664 was not finished. No guessing, just the facts. The sun rotates about once a month. A sunspot takes roughly 2 weeks to cross the face we can see. Then it disappears around the far side for another 2 weeks. And if it survives, it comes back around. Most active regions do not survive. They decay on the journey. They break apart. They arrive back weakened, or they never arrive at all. AR3664 came back swinging. Even before it fully returned, the sun told us it was coming. In late May, as the region approached the edge and rotated back into view, it announced itself with an X2.8 flare, then an X1.4, fired from just over the horizon of the sun. By then, it had merged with another region and been renamed. On the charts, it became AR3697, same monster, new number, and it kept firing. On May 27th, another X-class flare, an X2.9. Then, on June 8th, as it swung back toward the edge a second time, it released an M9.7 flare. And that one produced what NOAA identified as the strongest solar radiation storm since September of 2017. On June 10th, on its way out of sight again, it fired an X1.5 as a farewell. Then it went around a second time, and it came back a third time. By late June, the same restless region rotated into view yet again, renamed once more to AR3723, still throwing M-class flares, still magnetically alive after nearly 2 full trips around the sun. 1 active region, 3 passes across the face of our star, weeks of X-flares, radiation storms, and the most powerful geomagnetic storm in 20 years, all from the same knot of magnetism that first appeared as 5 quiet little spots on the 1st of May. And the sun as a whole was not calming down either. Europe's Solar Orbiter spacecraft, watching from an angle that lets it see the sun's hidden far side, recorded flares even bigger than anything AR3664 threw at Earth. An X12 in late May, and in July, an X14. That X14 stands as the single strongest flare measured in this entire solar cycle. It fired from the far side, so Earth was spared the worst of it. This time, purely because of where the sun happened to be pointing. That is the pattern you are left staring at. Not one storm, a season of them. A sun near the peak of its 11-year cycle, building monster after monster, firing them in every direction, and only the geometry of rotation deciding which ones come for us. No guessing, just the facts. So spell it out, fully, no drama, no exaggeration, just the scenario the experts actually plan for. Picture the next AR3664. Same size, same complexity, same string of X-flares and merged CMEs. But this time, the geometry is different. This time, the biggest eruption fires, while that region sits dead center on the face of the sun, aimed squarely at Earth, on an ordinary working weekday. And this time, the cloud that arrives is Carrington class, the kind we know the sun can build, the kind that missed us by a week in 2012. Here is what that convoy of plasma does when it arrives. It slams Earth's magnetic field and drives enormous electric currents through the ground itself. Those currents surge into the long metal lines strung across every continent, the high-voltage power grid. The most vulnerable pieces are the largest transformers, the ones that step voltage up and down at the backbone of the grid. They are not designed for a current that flows the wrong way through the earth beneath them. They can overheat. They can fail. And the largest of them are built to order, over many months, with no shelf of spares waiting. And here is the part that turns a bad night into a bad year. A large transformer is not a light bulb you swap out. The biggest ones are custom-built, ordered years in advance, and there is no warehouse of spares waiting for a continent-wide failure. Lose enough of them at once, and the question stops being how long until the lights come back on, and becomes how long until new transformers can be manufactured, shipped, and installed. A timeline measured not in hours, like Quebec in 1989, but potentially in months. At the same time, GPS degrades across whole continents, not by feet this time, but badly enough to disrupt aviation, shipping, financial timestamps, and the precision farming that feeds people. Satellites in low orbit sink in the swollen atmosphere. High-frequency radio blacks out over the daylit half of the planet. Some spacecraft go silent, and the aurora burns red, over cities that have never in their history seen it. The May 2024 storm did a version of every one of those things. The only reason it reads as a spectacular light show instead of a disaster is scale, and timing, and warning. Turn up the scale to Carrington, remove the lucky geometry, and the light show becomes the most expensive natural disaster in modern history. Studies estimate that the May 2024 class storm has a return period of roughly 12.5 years, not once a millennium, not once in a lifetime. Something in that weight class is expected again within the working career of the engineers alive right now. A true Carrington-class event is rarer, but it is not impossible. It has already happened once. It has already nearly happened again. AR3664 was not the disaster. AR3664 was the rehearsal. The sun showed us the gun, showed us it was loaded, and then, this time, turned its head at the last second. So here is the one thing to carry with you. The most dangerous object in the solar system is not some distant, exotic threat. It is the ordinary star you see every morning. And in May 2024, it built a spot 15 times wider than Earth, fired everything it had, and then reloaded and did it twice more. We track this sun as it develops, because the next AR3664 is not a question of if, it is a question of when and where it's pointing. Subscribe and stay with us, because the next time a monster rotates into view, you'll want to see it coming. Next up, the 2012 solar storm that missed Earth by 7 days, and what the scientists who studied it are still afraid of. No guessing, just the facts.